Let's now look at going back the other way. So how do we integrate the exponentials? So first of all, let's just look at if it's a linear function. So if it's a linear function in the power, then essentially you're just dividing by the coefficient of that. Because what you're really doing, and this is probably more useful, looking at it like this, if you can set the integral up so that you've got the derivative times the exponential to some function, because of course that was our answer once we differentiated, then we know we can go back and we've simply got e to the power of that function. Let's look at it. Here's e to the power of 5x. Well, linear function, so yeah, okay, it's pretty quick if you do think of it that way. You got 1 on 5 e to the power of 5x. Thinking about it the other way, whether you physically write this line down or not, but this is probably more the thinking of it, well, integral of e to the 5x, well, what I'd really like is the derivative times that. And the derivative of 5x is 5, so I would like the integral of 5 e to the 5x, but to balance it out, I would need a fifth out the front. I can do the integral, that would have come from e to the 5x. So for these simple linear ones, you probably wouldn't put that middle line of working out down, but that's sort of the thought process. It means when you now get something like this, you go, well, what I would like is 2x there, not just x, because the derivative of x squared is 2x. So I know I've got a half of 2x e to the x squared. That integral will go back to e to the x squared. That would be its primitive function. This one's a linear function the long way, a ninth, 9 e to the 9x minus 5, but it's probably quicker on that one to go, oh, well, it's just 1/9. Ooh, square root of e to the x, index laws, square root, that would be e to the power of x on 2, which is a linear function. But I would like a half e to the x on 2, so I've got 2 times that, so we'll get 2 lots of e to the x on 2. I'm always in the habit of writing my answer in the same format that they asked the question. The question was in surd form, I'm giving my answer in surd form. Well, we don't have a product for integration like we do for differentiation, so we're going to have to expand this thing out. That's what we're integrating. Now, all of those are linear functions, so yeah, it's definitely going to be quicker for this one to just go, that's a half e to 2x minus 2e to the x, and of course the 3 integrates to be 3x, but of course, plus a constant. Quotient rule, we don't have quotient rule. So index laws, e to the 3x minus e to the minus x. That's the one we've got to be real careful with the negatives and what have you. But we'd have a third e to the 3x, it'd end up being plus e to the minus x. Let's do a definite one. Not a linear function in the power, so I would like 3x squared out the front. I've only got x squared. So alright, I've got a third of what I want, so it becomes a third of e to the x cubed going from 0 to 1. Sub in the 1, sub in the 0. Well, anything to the power of 0 is 1, so we get a third of e minus 1. What about if the base is not e? Well, we saw how we handled that when we differentiated. And you recall when we differentiated, we multiplied by the natural log. Well, it makes sense if we're going back the other way, we'd divide by the natural log. So we do it the same, but we divide by the natural log of the base. So there's a handful of questions. Big hand, mind you, but it's a handful of questions.